Recently I made a video about repurposing old dead laptops, and in it we made many cool things, from laser VU meters that visualise sound waves in music, to fancy heat pipe based desk lamps, and even a decent sounding headset microphone. But with so many things to cover, one last important project couldn't be fitted in. You see, look at this poor laptop. It's been completely smashed, the screen doesn't work, there's a horrible bend in the side here. I mean, goodness knows what actually happened to it. But it's essentially unusable, as you can see. But remarkably, if I plug in an external monitor, the system does appear to still be working. Now this is, I think, quite amazing considering the damage, but really replacing the screen and trying to repair it is just not worth it because the plastics are bent and broken, and I think that we can do something a bit better than that. So what I'm going to do is, as the specs in this are still reasonable even by today's standards, I'm going to actually dismantle it and use it to show you how to build your very own all-in-one PC with a beautiful modern design. Now this will have all of the components built into it to make it a fully functional independent PC, including an absolutely phenomenal sound system. And it should be a fantastic use of an old smashed up laptop. So let's get to it. So to build an all-in-one PC out of a laptop, the first thing to do is strip down the laptop in an effort to remove the motherboard. This isn't particularly difficult, and like is the case here, often starts with the keyboard. I'm going to keep this to one side though, as it's going to be important later on. One by one, the plastics can be separated and removed as well, and all of the cables unclipped as you progress. With that done, you should now be left with the motherboard tray. If you look closely at mine, you can see the damage inflicted on it, and amazingly it appears as though it's only the heatsink and fan that are bent, with the PCB itself having had a very fortunate escape. Bending it back into position though reveals that one of the heat pipes has collapsed, which will definitely harm its cooling ability, and could mean that the fan itself will always run at maximum speed as it tries to compensate. Thankfully though, there are plenty of spares available on eBay for this particular laptop model, which is easy enough to swap out. So at this stage it's important to check whether the system can operate outside its casing like this, and the first challenge for me is actually going to be turning it on. You see, unlike most laptops, the power button on mine is actually part of the keyboard membrane itself, and cannot be separated. This poses a potential problem as I don't really want to leave this keyboard connected, but we'll cross that bridge when we get to it. Another potential issue, for everyone this time, is that without the built-in display we can't use it to access the BIOS, which is important for changing system settings and even sometimes installing Windows afresh. Thankfully though, most laptop manufacturers have thought of this, and added a function button that can be pressed to cycle through the various display outputs, allowing us to access everything with ease. So once hooked up to a power brick and monitor, the motherboard still starts up just fine, despite being out of its casing. Having a look at the BIOS menus, I found a few options which will help a lot for this particular build. The first being the boot display priority setting, which I set to always output to the DisplayPort first, negating the need to use the special function button. Another interesting option I found was labelled power on with AC attach, which may help me to still boot this while ditching the keyboard, but we'll see if that's possible later. Spec-wise, the laptop appears to have a reasonable processor, but the RAM is a little low at 4GB, so I replaced this with two 8GB sticks to give me a total of 16GB, bringing it in line with modern machines. As it didn't have any USB 3.0 ports though, I slid in a USB 3.0 expansion card that I had lying around, and also added a SATA SSD for the operating system storage. These upgrades should ensure that the system runs smoothly, and we'll assess its performance later on in the video. So, with the motherboard now checked and upgraded, it's time to really get going on this project, starting with a very important decision as to what monitor to build it into. Originally, I was just going to use this old Dell, which, while it is a good monitor with good colour accuracy, it's awfully big and bulky, and will only be made even more bulky as we add more components to it. I want this build to be as sleek as possible, so instead I've decided to go with a low-cost, slimline monitor, which will not only make the build much easier to put together thanks to the flat back, but it should also look very professional once completed due to the design we'll be using. So to get things going, we're going to mount all of the components onto a single piece of MDF wood that will then be mounted on the back of the display. You might think that this is a rather unusual material to use here, especially in an area where you can easily order aluminium sheeting, but I'll go through my reasoning for recommending it as we progress. So the first task is to mark the motherboard mounting holes onto this MDF, and drill these out with an appropriate drill bit. The underside of these holes can then be countersunk so that the heads of the screws we'll be using can be flush with the surface, meaning that they won't be in the way when it gets mounted to the back of the monitor. This is actually the first reason why MDF is a good choice here, as its thickness allows screws to be countersunk like this. These screws are actually for mounting some PCB pillars to support the motherboard, but before adding all of them, I, purely for aesthetic reasons, added some vinyl wrap to the MDF, which makes it look quite smart for this video presentation. The pillars can now be added and the motherboard screwed in place on top of them. This brings me to the second reason for choosing MDF, which is that it's actually a great material to glue other woods to, allowing us to simply glue in place some pine edging to function as the outer perimeter. This is an unusual material to use for a computer, but I think it will look rather nice once it's on the back of the screen. So before gluing on the rest of the edging, it's a good point in time to add any additional components and wires, like say the monitor cable, and in my case a USB 3.0 hub and card reader, so that these can be accessed on the side of the case. Any holes and slots for things like this can be cut in the side edging before they too get stuck in place. Now to get the angled corners so that they fit together at 90 degrees, I suggest using a miter saw. Now some of you eagle-eyed viewers will have probably noticed that I've included the laptop's battery here, and I'll explain the reasoning behind this later. So with most of the major components now mounted in place, we need to tackle something quite important for an all-in-one PC, which is the audio. As the laptop's original speakers are unusually abysmal, and the ones built into the monitor aren't much better, I'm going to experiment with using some integrated speakers that I salvaged from an old TV. Big shout out to Bob Trade for this, as they gave me the TV. Thanks guys! What's quite exciting about these is that they appear to be completely enclosed units designed by Harman Kardon and JBL, so I have high hopes for their sound quality. To prevent damage to the main drivers by, say, stray fingers, I glued in place a thin mesh to the front, and then added some thin fabric for appearances, which I kept in place with a little 3D printed border. These units could then be glued to the monitor at a downwards angle to project the sound waves underneath and forwards towards the listener. These look reasonably presentable from the front, and should provide excellent clarity. The subwoofer, on the other hand, can be mounted in the rear casing, as bass frequencies pass around objects more easily, so it doesn't matter that it's on the back here. With these speakers being pretty powerful, an amplifier needs to be used to get the most out of them. In my case, a stereo one was just fine because the speaker drivers themselves have crossover filters built in, as well as a mono mix for the subwoofer. Connecting it to the laptop's headphone port, I encountered two problems during testing however. The first is that it turns out that the audio quality from the headphone port on the laptop is very poor, with thin bass and grating treble. And the second is that because I'm powering the amplifier from the same power source that the laptop is running off, there's an inescapable interference noise that sounds awful, caused by what's known as a ground loop. To get around both of these sound issues, I bought a USB power isolator as well as a USB audio interface. Despite its price, this USB audio interface sounds much better than the laptop's original output, and because it receives its power through the isolator, which creates a new virtual ground, the ground loop is eliminated and the interference noise completely disappears. This results in extremely clean and clear audio, and I'll give you an example of it later as it really is very impressive. So at this stage, the system is almost ready to use, but there is one last important thing left to tackle, which is adding a power button to turn it on with. Now, as I mentioned earlier, I don't really want to leave the keyboard, which has the power button on it, connected, as it would make the thing look a bit bulky and also a bit weird. So instead, what I'm going to do is take advantage of the power setting option in the BIOS that enables the laptop to turn on when it detects that it's receiving DC power. So to make this a practical solution, I routed the power through a momentary push switch. Normally this breaks the circuit, But once pressed, the power goes through to the laptop, which then decides to turn itself on thanks to the BIOS setting. In doing so, the USB ports start receiving power, so I attached a relay to one so that it takes over from the momentary push button so that the power can still get to the laptop once the button is released, only through the relay now. When the system is shut down, the USB power drops out and the relay then clicks off, disconnecting the laptop, leaving it primed, ready to be turned on again whenever needed. This also means that I can power the amplifier and also the monitor itself from the same power brick, as these both get disconnected when the laptop is off, making them properly integrated into the system. One minor downside is that the system won't boot if it's not connected to the mains, despite having the laptop's original battery included and built in. That's fine by me though, as the system is intended for desktop use, and my only reason for including the battery is to allow the system to be unplugged and moved to an adjacent room, without having to be shut down first, which I can imagine coming in useful on occasion. So the last job is to cover up all of these components, for which we need to make a back panel. I'm just going to make mine out of a sheet of aluminium, which, after being cut down to size, can have various openings made in it for airflow purposes and the speaker. If you do this too, you might want to sand it down in one direction to give it a brushed appearance. And to give something to screw this panel to, I recommend just adding some little wooden blocks to the inside of the case, which can then have some small inserts adding, which will allow us to use machine screws to secure the back panel in place. Looking closely around the fan area, you can see that I also added some small cups to direct the flow of air, which are just little 3D printed shapes that I glued in place before the panel got put on. If you want to do something similar without a 3D printer, you can probably get away with making these out of acetate instead. So with the back panel now in place, it's actually ready to be mounted on the back of the monitor. But before I do that and then evaluate the system's performance as well as the audio quality, which should be very interesting with these speakers, I want to talk about this video's sponsor, Blinkist. With so much information literally available at our fingertips these days, it's sometimes quite difficult to condense things down and find knowledge that's worth listening to, and sometimes the finding can take longer than the reading. Solution? Spend hours reading books? I don't have time for that. This is where Blinkist comes into play, as they take key insights from over 3,000 non-fiction bestsellers across many different topics and gather them into 15-minute blinks, which are condensed explainers that help you to understand the core ideas at hand, which you can either read at your own leisure or, even better, listen to, which is great for when you're perhaps commuting to work or working out. One feature I love is the Surprise Me button, which will take you on a dive into topics and ideas that may have never occurred to you otherwise. Now, if you have similar interests to me, a good one to start with is The Laws of Thermodynamics, which is a fascinating introduction to the wonderful world of thermodynamics and how it affects our everyday lives. So if all of this sounds good to you, visit blinkist.com/DIYperks for a completely free 1-week unlimited access trial. And if you decide you like it, you can get 25% off using that link as well. So again, that's blinkist.com/DIYperks to get learning today. So to mount this on the back of the monitor, I'm actually going to use epoxy. Now this is a very permanent solution, but I bought this monitor specifically for this project, so I'm happy committing it to the job at hand. So after mixing this epoxy up on the back of the monitor, the system can be carefully placed on top and left to dry. On the back here you can see that I've glued the Wi-Fi antennas to the bottom so that they aren't blocked by the aluminium, which leaves me with one last very important job. As you can see, the build does look modern and sleek, and would be great on any desk setup, especially thanks to the raw natural wood being integrated fittingly into its design, as it provides a contrast to the matte display and aluminium backplate. So with it complete now, the last thing to do is to test it out. So I've got the laptop's original power connection here, which can just be plugged in the back, And as you can see, despite the BIOS setting, it hasn't turned on, and that's because the push button is blocking that power from reaching the laptop. So if I just press it, the laptop will detect it, turn on, and then the power will start going through the relay instead. So let's see if that works. Right, perfect. So that pop there was the amplifier turning on as well, because the monitor and the amplifier get powered up basically as soon as the laptop turns on. Having already installed Windows, the system boots up quickly, and giving it a quick test, its performance doing normal everyday tasks is absolutely fine, to the point where I'd be happy using this on a regular basis. Doing photo or video editing might be a bit of a stretch on it, but that's okay. It is, after all, a repurposing project, and for the money invested in it, it definitely provides a lot back. A unique, beautiful build that looks neat on a desk and has a lot where it counts. Excellent usability and superb sound quality. Speaking of which... Now, hopefully you can hear this at home, but this is a very full, rich sound, and I'm so impressed that this is in a package that's that thin. Those speakers are awesome. Cool. So I hope you've enjoyed watching, seeing how to make your very own all-in-one PC, and if you do this yourself, have fun, be creative, and just enjoy the process, because it's pretty cool repurposing something that's otherwise scrap into something that's actually really usable and incredibly unique. So thanks for watching, and don't forget to subscribe and like and all that good stuff. But other than that, I'm Matt, you've been watching DIY Perks, and I hope I see you next time. Goodbye for now. If you like my work, please consider supporting the channel on Patreon at patreon.com/DIYperks. Many thanks for your support.